Here's lesson 4, quadratics in factored form. Earlier in the unit, we looked at quadratics in both standard form and vertex form. And you learned that in the standard form equation, the c value tells you the y-intercept of a quadratic. In vertex form, the h and k parameters tell you the coordinates of the vertex. And in both of the formats, the a value tells you the direction of opening. If a is positive, the parabola opens up. If a is negative, the parabola opens down. But in this lesson, we're going to focus on factored form. And this third format we can write quadratic equations in is very important because these parameters r and s tell us about a very important property of quadratics. Let's do an investigation here in part 1 so you can see what these parameters r and s tell us about a quadratic relationship. In this example 1, it says that if we are given the graph of y equals 2 times x plus 3 times x minus 5, and I see the graph over here, part A wants us to state what the x-intercepts are and how they relate to this equation. So let's start by looking at the graph and labeling the x-intercepts. An x-intercept is where the parabola crosses the x-axis. I see it crosses in 2 spots. The quadratic has an x-intercept at the point negative 3, 0, and also at this point over here, the point 5, 0. So I'll write those down in part A. The x-intercepts are at the points negative 3, 0, and 5, 0. And the second part of this question is very important. How do those x-intercepts relate to the equation? So these x-intercepts of negative 3 and 5, how do they relate to the equation of the quadratic? Well, notice the y-coordinates of both x-intercepts are 0. And the y-coordinate of any x-intercept is going to be 0. Meaning, these are the x-coordinates that make y equal to 0. So subbing in either of these x-coordinates, either negative 3 or 5, for these x values, would make this equation be 0. And let me demonstrate that for you. If I were to sub in negative 3 into this equation for x, this equation would simplify to y equals 2 times 0 times negative 8. So I have a product of 3 factors, and notice one of those 3 factors is 0. When one of the factors in a product is 0, that makes the whole product be 0. So I can see that subbing in negative 3 for the x values makes the y-coordinate be 0, which is why it is an x-intercept on the graph. And what would happen if I subbed in 5 for x into this equation? Notice when replacing x with 5, it's going to make this third factor be 0, which makes the whole product be 0, so the y value is 0 when x is 5. So these x values of negative 3 and 5 are the values of x that make this whole product become 0. They make the y-coordinate of the function be 0. So I could say that negative 3 and 5 are the zeros of the equation, which just means they're the values of x that make the equation be 0. So what you should have figured out in part A is that if there is a value of x that makes any of the factors of the factored form equation be 0, that value of x would be an x-intercept on the graph. Right? X plus 3 would be 0 if x was negative 3, and x minus 5 would be 0 if x was 5. So if x was either of those values, it would make the whole product be 0, which means it makes the y value be 0, which means it is an x-intercept on the graph. And now part B, let's relate these x-intercepts, negative 3 and 5, let's relate those to the vertex. Part B says, what is the vertex? We'll start by answering that. So let's look at the graph. The vertex is the minimum point, which has coordinates of 1, negative 8. So we'll jot that down. The vertex is at 1, negative 8. And because parabolas are symmetrical, you should notice that this x-coordinate of the vertex, 1, is the average of the x-intercepts, negative 3 and 5. The vertex, horizontally, is always going to be right in the middle of these two x-intercepts. And that's because parabolas are symmetrical about the axis of symmetry that goes right through the vertex. So I'll say the x-coordinate of the vertex is the average of the x-intercepts. And to demonstrate that to you, to find the average of two numbers, to find the average of negative 3 and 5, you just add them and divide by 2. So negative 3 plus 5 divided by 2 would be 2 over 2, which is 1, the x-coordinate of the vertex. And part C says, what's the equation of the axis of symmetry? Well, the axis of symmetry is the vertical line that goes through the vertex. And the equation of any vertical line is x equals the x-coordinate of all the points that make up the line. All of the points on this line all have x-coordinates of 1. So of course it's going to match the x-coordinate of the vertex because it goes through the vertex. So the equation of the axis of symmetry is x equals 1. And what's the direction of opening of this parabola? Well, this parabola clearly opens up. And that happens because in the equation, the a value, the constant factor in front of the factors of x, is positive. So it's always going to open up when the a value is greater than 0. And now let's summarize the properties of a factored form equation that we should have learned in that investigation. So in this general factored form quadratic equation, y equals a times x minus r times x minus s, the x-intercepts would be the values of x that would make this whole product be 0. Well, the whole product would be 0 if any of the factors were 0. And x minus r would be 0 if x was equal to r. And x minus s would be equal to 0 if x was equal to s. So in that factored form equation, we could say that the x-intercepts are at r and s. And in this factored form equation, this a value, just like in vertex form or standard form, tells us the direction of opening. If a is greater than 0, it opens up. And if a is less than 0, it opens down. The x-coordinate of the vertex, because parabolas are symmetrical, the x-coordinate of the vertex is going to be the average of the x-intercepts, r and s. And we could find their average just by adding them and dividing by 2. And the axis of symmetry is the vertical line that goes through the vertex, so its equation will be x equals the x-coordinate of the vertex, which is r plus s divided by 2. So the equation of the axis of symmetry is x equals r plus s over 2. And now let's move on and use these properties to answer a few questions. In example 1, it says, given the following quadratic equations, determine number 1, the x-intercepts using the zero product rule. Number 2, the equation of the axis of symmetry. 3, the vertex. And then 4, graph the quadratic. Let's start with part 1, which says, for this quadratic, find the x-intercepts. Well, x-intercepts are the values of x that have a y-coordinate of 0. Right? They're the points that cross the x-axis, and any point on the x-axis has a y-coordinate of 0. So to find the x-intercepts in part 1, the first thing I should do to communicate what I'm doing is set this y-coordinate equal to 0. And now I just have to figure out how can the product of these three factors be 0. Well, using the zero product rule, which is stated over there on the right, a product of three factors would be 0 if any of those three factors were 0. Well, 2 can't be 0, it's constant, but x plus 1 could be 0. If I solve this equation, I would figure out x plus 1 would be 0 if x was negative 1. And x minus 3 could also be 0. X minus 3 would be equal to 0 if x was 3. So these two values of x make this whole product be 0, meaning it makes the y-coordinate be 0. So these are the x-intercepts of the quadratic. The x-intercepts are at negative 1, 0, and 3, 0. So I'll plot those on my graph, on the x-axis at negative 1 and 3. And then for part 2, I have to find the equation of the axis of symmetry. Remember, the axis of symmetry is the vertical line that goes right through the middle of the parabola. So it's going to be at the average of the two x-intercepts. So to find the equation of the axis of symmetry, it'll be at x equals the average of these two x-intercepts, negative 1 and 3. And to find the average of two numbers, you can just add them, negative 1 plus 3, and then divide them by 2. Negative 1 plus 3 is 2, so I have 2 divided by 2, which is 1, which means the equation of the axis of symmetry is x equals 1. And I could graph that on my grid. And then part 3 wants us to find the vertex of this quadratic relationship. I know that the axis of symmetry goes through the vertex, so the vertex is going to be along this axis of symmetry somewhere. So I know the x-coordinate of the vertex is going to be equal to 1, but what's the y-coordinate of the vertex? To find the y-coordinate, we can just take the x-coordinate of the vertex and sub it into the equation for x and calculate y. So the y-coordinate of the vertex would be equal to 2 times 1 plus 1 times 1 minus 3. And simplifying those factors, I see the y-coordinate of the vertex is 2 times negative 2, which is negative 8. So the vertex is at the point 1, negative 8. So I can move that point down so it has a y-coordinate of negative 8. And now to graph the quadratic, I could now just connect those points, and there's my quadratic. But to be a little bit more accurate, I think it would be good if we found the y-intercept as well. Where does it cross the y-axis? Well, wherever it crosses the y-axis, its x-coordinate would be 0. So I can just sub 0 in for these x's and get the y-intercept. Subbing in 0 for x, I have 2 times 0 plus 1 times 0 minus 3, which is 2 times 1 times negative 3, which is negative 6, which means the y-intercept is at negative 6. And then because parabolas are symmetrical, I know one to the right of the vertex, it'll be at a height of negative 6 as well. And now connecting these points, I'll have a more accurate graph of the quadratic. And now let's move on to part B and graph another one. This time our quadratic, still in factored form, is a product of a half times x plus 6 times x plus 2. Because it's in factored form, it would be easy to find the x-intercepts. I can just set the y-coordinate equal to 0, and then solve for what makes the product of those factors be 0. Factored form is great because it's easy to see what makes a product be 0. The product would be 0 if any of these factors were 0. Well, x plus 6 could be 0 if x was equal to negative 6, and x plus 2 could equal 0 if x was equal to negative 2. So the x-intercepts are at negative 6 and negative 2. I can plot those on my graph. Negative 6 and negative 2 are the x-intercepts. And then part 2 of this question, it wants us to find the axis of symmetry, which is going to be x equals the average of the x-intercepts. So negative 6 plus negative 2 divided by 2, which would give me x equals negative 8 over 2, which is x equals negative 4, is the equation of the axis of symmetry. So I can graph that on my grid as well. And then I know the vertex is going to fall along that axis of symmetry somewhere. So the x-coordinate of the vertex is going to be equal to negative 4. And to get the y-coordinate of the vertex, we'll have to sub that negative 4 into the factored form equation for these x's. And simplifying this, I get a half times 2 times negative 2, which is equal to negative 2. So the vertex is at the point negative 4, negative 2. And I can plot that on my grid. And just like last time, let's be a little bit more accurate. Let's find the y-intercept as well. Wherever it crosses the y-axis, its x-coordinate will be 0. So I'll just calculate y by subbing in 0 for these x's. And evaluating this, a half times 6 times 2 is 6. So the y-intercept is at 0, 6. And then because parabolas are symmetrical, 4 units to the left of the vertex, it'll be at a height of 6 as well. And then I can connect the points. And let's do 2 more that will pose a couple challenges. Part C, notice that this quadratic is actually in standard form. And for part 1 of this question, we want the x-intercepts, which are the values of x that make y 0. So if I set y equal to 0, I now need to find what values of these x's make the sum of these terms be 0. Well, finding when a sum of terms is 0 is a lot more difficult than finding when a product of factors is 0. So we actually need to get this into factored form to be able to figure out what makes it be 0. And from the last unit, we learned how to factor quadratic trinomials with a leading coefficient of 1 using a sum and product factoring method. We just have to find numbers that have a product of the c value and a sum of the b value. The numbers that multiply to negative 8 and add to 2 are 4 and negative 2, which means I could rewrite that standard form quadratic in factored form as x plus 4 times x minus 2. And now that it's in factored form, it will be a lot easier to see what makes this quadratic be 0. The product would be 0 if either of these factors were 0. Well, x plus 4 could be 0 if x was negative 4, and x minus 2 could be 0 if x was equal to 2. So the x-intercepts are at negative 4 and 2. Part 2, we have to find the equation of the axis of symmetry, which is always x equals the average of the x-intercepts. So just add negative 4 and 2 and then divide by 2. And that gives me x equals negative 2 over 2, which is x equals negative 1. So if I plot my x-intercepts at negative 4 and 2, I can see that the axis of symmetry, the line that goes through the middle of the parabola, will be at x equals negative 1. And then I know the vertex is going to be on that axis of symmetry somewhere. So in part 3, I can record that the x-coordinate of the vertex is going to be negative 1. And then to get the y-coordinate of the vertex, I could sub this x value of negative 1 into either the standard form equation or the factored form equation. They are equivalent to calculate the y. I'll sub it into standard form. Simplifying, I have 1 minus 2 minus 8, which would give me negative 9. So the vertex is at negative 1, negative 9. And even though the question doesn't ask, let's find where it crosses the y-axis as well. Wherever it crosses the y-axis, the x-coordinate will be 0. So I'll find the y-intercept by just setting the x's to 0 either in the standard form equation or the factored form equation. Either way, when I do that, I would figure out that the y-intercept is at negative 8. So I can plot a point to the right of the vertex at negative 8, and to the left it'll also be at a height of negative 8. And then connecting those points, I have the graph of the parabola. And lastly, let's do part D. Part D, the quadratic, once again, is given in standard form. So to do part 1, where we want the x-intercepts, which are the values of x that make the y value be 0, so I'll set y to 0, I need to solve this. And because there's only one term with a variable, there are a couple options for how to solve this, but I'd like you to get in the habit of factoring it if possible. And this is factorable. It's a difference of squares. That x squared minus 9, you can think of it as an x squared minus a 3 squared, which is clearly a difference of squares. So based on the rule, that would factor to x minus 3 times x plus 3. And now that this is written in factored form, right, it's just a product of factors, the product would be 0 if either of these factors were 0. X minus 3 would be 0 if x was 3, and x plus 3 would be 0 if x was negative 3. So the x-intercepts are at 3 and negative 3. And then for part 2, the equation of the axis of symmetry, the axis of symmetry is going to be right in the middle of the x-intercepts. The middle of 3 and negative 3 is 0, but we could calculate it by adding them and dividing by 2. That gives 0 over 2, which is 0. So the equation of the axis of symmetry is the vertical line x equals 0. And the vertex is going to fall on that axis of symmetry somewhere. So the x-coordinate of the vertex is going to be 0. And to get the y-coordinate of the vertex, we can just take that x value of 0, sub it into either the standard form equation or the factored form equation for x, and then calculate y. I'll sub it into the standard form of 0 squared minus 9, which tells me the y-coordinate of the vertex is just negative 9. So the vertex is at the point 0, negative 9. And then connecting those points, we have the graph of this parabola. And now the last thing to do in this lesson is to go the other way. What if I give you the graph of the parabola and we come up with the equation in factored form? Well, to do that, we start by identifying the x-intercepts and make those the r and s values in the factored form equation. Let me just write out the factored form equation. Y equals a times x minus r times x minus s. Remember, the x-intercepts are the values of x that make the factors be 0. And these factors would be 0 if x was either r or s. So whatever the x-intercepts are, in this case 0 and 6, we make those the r and the s values. We then find some other point xy that's on the graph of the parabola, which I see here is the point 3, 3. And we can plug those values, the x and y, along with the r and s values, into this factored form equation, and then solve for a. So let's go ahead and do that for this question. So once again, on this graph, we find the x-intercepts, and we make the x values of the x-intercepts, the r and the s values, in the factored form equation. And then we make some other point our xy point. And then into our factored form equation, I can sub in that x, y, r, and s. And then all I'm left with is this unknown value of a. So I can solve this equation for a. Starting by simplifying these factors to 3 and negative 3, I see the right side of my equation, the product would be negative 9a. And then isolating a, I would divide the negative 9 to the other side, and I figure out a is equal to negative 3 over 9, which I could simplify to negative a third. And then writing my final equation into my factored form, I sub in for a, and my r value was 0, and my s value was 6. Now we of course wouldn't write x minus 0, we would just write that as x. So let me change that. And there's the final answer. That equation defines all of the points that make up this parabola. Hopefully you could see clearly that this factor would be 0 if x was 0, which is why we have an x-intercept at 0. And this factor would be 0 if x was 6, which is why we have an x-intercept at 6 on the graph. And then calculating this a value is necessary because there's an infinite number of parabolas that have those two x-intercepts. but this very specific parabola has to pass through that point 3, 3. So let me go into Desmos to show you why we had to solve for that value of a. So here's a parabola with x-intercepts at 0 and 6 with an a value of 1. Notice it doesn't go through that point 3, 3. But changing the a value, notice it doesn't change the x-intercepts of the parabola. But it can make it go through that point 3, 3 if we make the a value, as you can see, -1/3, which is what we calculated in the question. And now let's go ahead and try a second example. For the graph of this quadratic, let's come up with its equation in factored form as well. So I'll write the template for factored form, and remember r and s are the x-intercepts of the quadratic because those are the values that would make these factors be 0. So the x-intercepts of this quadratic are at -1 and 4. So we can make -1 the r value and 4 the s value. And then I could sub those into my factored form equation for r and s. And you can see that I have an x minus a -1. We could simplify that to just x plus 1. And now I have to solve for this value of a that makes this parabola with those x-intercepts at -1 and 4 have that exact shape. So I need to pick another point, any other point that's on this parabola. I think I'll pick this y-intercept of -8. That's the point 0, -8. That's an xy point that is on the parabola. So I need to solve for what value of a will make this parabola go through that point 0, -8. So I'll sub in for x and y, r and s, and then solve for a. Simplifying these factors to 1 and -4, I can see that the right side of this equation would be a times 1 times -4, which is just -4a. And then dividing the -4 to the other side, I can see that the a value is just going to be equal to 2. So my final factored form equation, I can just take this a value of 2 and sub it into that version right there. And there's my final answer. Notice this factor would be 0 if x is -1, which is why there's an x-intercept at -1. And this factor would be 0 if x was 4, which is why there's an x-intercept at 4. And now let's do one last question. This time it doesn't give us the graph, it just describes it. It says determine the factored form equation of a parabola with x-intercepts at -3 and -5 and passes through this point. Well, the x-intercepts in the factored form equation, let me write that out. The x-intercepts correspond to r and s. And we know it goes through this point here, -4, 1. That's an xy point that's on the parabola. Subbing in all 4 of those parameters, my only unknown would be a, and I could solve for it. On the right side of the equation, -4 minus -3, that's -4 plus 3, which is -1. And then -4 minus -5, that's -4 plus 5, which is +1. So I have 1 equals a times -1 times 1 is -a, which means a is equal to -1. So I can write my factored form equation by subbing in for a, r, and s. So the equation would be y equals -1, which I'll just write as negative, and then x minus -3, which I'll write as x plus 3, and then x minus -5, which I'll write as x plus 5. And there's my final factored form equation. From this equation, I could see that there would be x-intercepts at -3 and 5 because those values would make these factors be 0, making the whole product be 0. And then one last thing I want to show you before I end the video. Let's look at a scenario where a quadratic has x-intercepts at, let's say, 4, 0 and -0.5, 0. We didn't have any x-intercepts in the video where they weren't integer values. -0.5 is not an integer. So how do we create a factor that has an x-intercept, a 0, of -0.5? Well, it's easy to create a factor that has a 0 of 4. We can just think that the answer to the equation that was set to 0 was 4, and then set it back to 0. Just move this 4 back over, and we figure out that the equation x minus 4 equaling 0 is the equation that would have this answer of x equaling 4, which means x minus 4 must have been a factor in the equation. So x minus 4 would have been a factor. But what equation would have an answer of -0.5? You might be tempted just to move this over and make it x plus 0.5 equals 0, and therefore making the factor in your equation x plus 0.5. Now that's not wrong, but usually when you have a factored form quadratic, you should only have integer values as the coefficient and the constant added. So instead of x plus 0.5, we're going to rearrange this equation here in 2 steps. We could start by multiplying this 2 to the other side, having 2x equals -1, and then add the 1 to the other side, having 2x plus 1 equals 0. And you can see that that factor of 2x plus 1, that factor would be 0 if x was -1/2. So you would use this, 2x plus 1, as the factor in the equation instead of x plus 1/2. So hopefully that made sense, and you'll know what to do if you encounter any rational values as the x-intercepts. So you can go to jensenmath.ca, get a copy of the free worksheet that goes along with this section, and practice these questions.
Jensen